Imagine you are an air traffic controller. You're given rapid instructions on the location and movement of airplanes, and you have to maintain those instructions and details, maybe even regarding multiple different aircrafts, in order to make accurate decisions. Whether you can stay focused and hold those details in mind depends on one key ability: attention control, which is our capacity to stay focused on what matters and ignore what doesn't. My research will investigate how the brain uses attention during working memory tasks and how we can measure it in real time. To get there, let's start with something simpler. Instead of hearing many instructions, imagine just hearing the difference between two sounds. Over 100 years ago, a psychologist named Charles Spearman discovered that people who were better at telling two almost identical tones apart tended to score higher on intelligence tests. He believed that there must be a central function that links perception, like hearing a tone, to complex thinking. Modern research suggests that this central function is attention control, and in fact, when scientists account for someone's attention abilities, that old link between basic hearing and intelligence disappears. In other words, attention seems to be the bridge between simple tasks and complex thinking. Attention control also plays a major role in working memory, which is the mental workspace we use to hold and manipulate information. As an air traffic controller, this is how you would store all of those different instructions and details. However, it isn't just about storage. It's about using attention to resist distractions, update information, and stay on task. People with stronger attention control tend to perform better in working memory and in higher level skills like reasoning and problem solving. But attention is invisible, and we can't watch it happening just by looking at behavior. So how can we measure it? Using something more quantifiable, like maybe EEG. This is what my task uses. So in my experiment, our participants will hear two tones, either differing in pitch or duration. They must decide which tone was higher or which one was longer. The key moment in this task is the time between the tones. This is the maintenance period where the brain has to allocate attention to hold the first tone in memory while preparing for the second. EEG will allow us to examine the brain activity during this maintenance period. Our study then will determine the patterns of EEG during the maintenance period that are associated with different levels of attention control and accuracy results. This will allow us to understand the neural mechanisms that underlie attention and working memory, as well as the efficiency of how those resources are allocated. Both of these elements will contribute to the theoretical understanding of attention control and working memory, which will strengthen future research in the field. However, these correlations could also open doors to real-world applications. Imagine a machine learning model that could predict performance accuracy. This model could be used to potentially predict lapses in judgment by the air traffic controller. It could also be used to better training programs, skill assessments, or other applications, and this could be possible by training a model using the patterns and associations determined by this study.